This is Mrs. O'Neill for AP Chemistry, Chapter 2, Section 9, some simple organic compounds. And I'm actually going to go through this quite quickly because we just learned this in Chapter 24. But they also put this in Chapter 2 because of the naming component. So I'm going to go through this rather quickly because it's just, again, a review of the information we already learned in Chapter 24. So your objective, obviously, is to understand organic chemistry and how the element carbon plays a big role. So if we look at these three compounds, they are organic compounds because they all contain carbon and they all contain hydrogen. So that would be a hydrocarbon. But let's look at the name: methane, hethane, propane. So what's the same about these three compounds? Hopefully you figured out that they all end in A-N-E, right? They're all single bonds. They all have that ane ending. So hopefully it comes to mind that these are alkanes. So then what's different about them? The number of carbon atoms, and that's where the prefix comes up with, right? Meth, eth, and prop. Those are your prefixes versus your ending. So an alkane is a hydrocarbon that only has single bonds. Oh, again, I want to remind you, pause the video, fill in the blanks in your packet, and then play to hear my words. So here's a way of looking at them, and again, we learned this early on about how you can do the structural formula, you can do the ball and stick formula, and you can do the space filling model as well. So again, these are just different ways of drawing them. And we want to remember that these are the formulas, but this is the structure and how you put that together. So there are branched or chains or groups that come off of the how do we want to say the parent? Yes, this is where it is, the parent hydrocarbon. So here we have the parent hydrocarbon, or the longest chain we used to call it, and this is your substituent, or I like to just say them groups. It's not a hard word for me to say. So we're going to have to name those groups that are coming off of that longest or the parent chain. So we want to also remember when we name the group that's off of that parent chain, we're going to change the ANE to the YL. So if we have a methane group, a one carbon group, we're really going to change it to a methyl name. Or if we have a two carbon group, we're going to change it to an ethyl name. So all we're doing is changing it to a YL at the end. So there are other functional groups, if you want to call it. So if we look at this again, methane changed to methanol, ethanol, and 1-propanol. And we'll talk about why that 1 is there in a minute. So what is the same between these three? Oh, sorry, I guess I don't have the answers. The same is the OH, right? That makes it an alcohol. And again, what's different is the amount of carbons. So let's look at this 1-propanol. Hopefully you remember back in Chapter 24, we have to name the groups. So if this is our longest chain, we're going to number this 1, 2, 3. So the OH, or the alcohol, is on the first carbon. There's also something called 2-propanol, and that's because, again, the longest chain is 3, but that OH group, that alcohol group, would be on that second carbon. So here again is to look at your methanol, your ethanol, your propanol, and your isopropyl alcohol. Okay, so what's the difference here? Remember how I was talking about the 1-propanol here because the 1's attached to the carbon? Well, if we put it here, the formal way is to name it 2-propanol, but you could also, a lot of times, because they are so common, or the compound, there's just an abundance of it, they give it a common name. So here we have a common name called isopropyl alcohol. So sometimes you'll hear this as propyl alcohol, and this is isopropyl alcohol. And what's the difference? Again, it's where that OH is bonded. Which carbon atom from the parent or the longest chain is that OH attached to it? Again, we looked at these in Chapter 24. So if you need to, go back and make sure that you remember these groups, especially the ones that we learned, the amino, the alcohol, the carboxylic. That's going to be real important in acids, ester, and the ketones. So make sure that you know those again. And again, here's just a nice visual if you want to pause the video and make sure that you understand the differences between an ane, an ene, and an ine, and a cyclol. So make sure that you understand what's going on there. So an alkene, like we talked about before, is the double bond. It only has to have one double bond to be an ene. So here is your smallest ethene. And then, of course, we have 3 carbons, 4 carbons, and so on, and then the different namings because of the different groups. But if it has one double bond in it, we're going to call it an alkene. And again, we have to label where that double bond is. And an alkyne, of course, is a triple bond, and same kind of situation. As long as it has one triple bond, it will be an alkyne. So why are these acids considered organic? You know, we have just that one carbon, but we're still going to consider this organic, and it's because of that carboxylic group. So we here have that COOH, COOH, so we have that carboxylic group. So and this is going to be a big one. This one, try to keep this one in your head. This acetic acid, which is really in vinegar, they use that a lot, especially as a weak acid when we get to acids and bases. And we want to remember that these organics molecules, they give us the flavor and scents. So if we took something like ethyl alcohol and butyric acid and we combine them, water is released, and when they combine together to make this long chain, they actually make a pineapple flavor. So when you're going to Rita's and you're eating all of that flavored ice, a lot of times it's because of these organic reactions that have occurred to make those flavors. Isomers, we talked about this again before, compounds with the same formula, but they're going to have a different arrangement of their atoms. And an example is the 1-propanol versus the 2-propanol. Again, I talked about that already. So here I'm going to go through the comparisons between inorganic, which would be all elements, and organic, that would be carbon containing. So you can read over that. I tried to make the similarities right next to each other in your notes so that you will be able to do a visual and understand the differences. So again, inorganic versus organic, notice it's just carbon and hydrogens all the way through. But inorganic, now they're going to use colors, and that's what you're going to see throughout the course and throughout your textbooks, that they're going to use different colors for different elements. So carbon is usually black, hydrogen is like this grayish or white, and then you come down here, you're going to have oxygen's red, nitrogen's blue, and they're going to have other things as well. But just keep that in mind. So sometimes that's why they like this ball and stick or the spatial molecules, because of the color visualization that goes along with it. And that's it. I don't know if most of you know this, but this is a typewriter. I'd love to know how many of you guys have ever seen or dealt with an actual typewriter before computers came around. All right, I'll see you in class.